This is Josh White with JW Math Tutoring, and this video is going to cover the calculator section from the October 2021 SAT QAS, the math portion from it, obviously. Now, just a couple things to be aware of. As I mentioned on almost every video, the solutions that I go through are a bit more detailed than some other videos out there, so they may take longer. These videos, a lot of times, will have multiple solutions to a single problem, including like 2 or 3 different ways to solve the problem. So just be aware that um, these videos again might be longer than the allotted time that you have to complete the specific section of the test, whether it's an SAT or an ACT exam. And the other thing is on this video, in the first half towards the end of it, so like around between problems 10 and 19, there's some issues with the recording where the video does not appear to keep up with the audio and might appear a little bit choppy. But the audio should come through cleanly. So even though the video might appear to be frozen, the audio itself, I mean the video I'm talking about like the webcam of me, but the audio itself should be good, and also the actual writing on the screen should not have an issue, except it might be a little bit jumpy. So I apologize for that.
But life is a dream the calculus could never predict.
Starting off with section 4, the calculator section from the math portion of the October 2021 SAT QAS. So, looking at problem 1, this is a relatively basic problem because they give you the equation here for how to find the density of an object. They just tell you it's mass divided by volume. So you just take the mass that you're given, which is 10. You divide that by the volume you're given, which is 12.5. And then you just divide that on the calculator, and the answer you should come out with is just going to be letter A, 0.8. And that's it. No other work or anything else that you need to do for that problem. Now, below that, problem 2, here we have a box plot. And they want to know the median number of seats for a state, basically in the U.S. House of Representatives. So when you have a box plot, just review a couple things real quick. The median is going to be equal to the line that you see in the middle of the box. So basically, wherever this line is, that is going to be the median. So for this problem, the answer is just going to be 5. It's going to be letter B. But just to review a couple other things, from the left edge, like basically like the left whisker to the start of the box, this is like this right here is the first quartile. It's like the lowest 25% of values. And then from the edge of the box to the line is like the next quartile, or in other words, that would make up the next 25%. Therefore, you have 50% total, from here to your median. And then the other 50%, is from the median and all the higher values, like 25% inside the box here, and then the other 25%, from the edge of the box up to the end of the whisker. All right, top of the page, problem number 3. So, a couple things. First of all, notice here that the calf, it says, is expected to gain weight or gain pounds. So right off the bat, we know it's going to be increasing, so get rid of B and D. And it's going to be increasing linear because it is gaining a specific number or specific value. If it was increasing by a percentage, then we would have an exponential function. But when it talks about increasing or decreasing by a specific known number or value, that describes a linear function. Again, exponential functions are going to increase or decrease, by a percentage, or something like, twice or 3 times or 4 times or half or whatever, where you're multiplying. Turning to the next page, we have problem number 4 here at the top. Now, there's multiple ways you could do this one. Obviously, you could take each of these lines and you could graph them on a graphing calculator, and then you could just see which things match. So maybe I'll do that for the first method, and then just show you how I would do it without actually using the graphing calculator. So for the first line, let's see, we've got negative 1/2. I'll just put that in parentheses, then times x minus 3. And then our second line is going to be negative 5x minus 7. Okay, so we'll graph them out. Looks like the first line is going to be fairly flat, and obviously it has a negative slope. Oh, it looks like I had the shading on for an inequality, but that doesn't really matter. But we can just get rid of that, just so that doesn't distract the graph here. So let's send this back to a line. All right, so let's redraw on the graph. If we go down through A, looks like a possible match for the first line. B, we do not see anything that looks like that, so we can get rid of that. Same thing with C, we don't see anything that looks like that. And D, we do have a possible match. Okay, now we have the second line on the screen. And when we look at the graph, D looks pretty close to it. Let's just scroll up and look at A. Okay, A is clearly not correct because both of the lines here have negative slopes, but in A, this line right here has a positive slope. So this is wrong. Correct answer is going to be letter D. Now, if you did not want to graph them on the graphing calculator, or you didn't have a graphing calculator, then I would basically just go through and essentially like match up the lines based on their slope and the y-intercept to the graphs. So just to show you an example real quick using some process of elimination, I'm just going to get rid of these marks first. Okay, so I'll take the first line. Okay, I'd notice slope is negative 1/2 and its y-intercept is negative 3. All right, so if we go down here to A, do we see a line with a y-intercept of negative 3? Yes, this line right here. Does it have a slope of negative 1/2, which is going to be pretty flat? So it's like down 1, right 2, down 1, right 2, down 1, right 2. Yes, so this one checks. When we look at B, do we see a slope line with an intercept of negative 3? Yep, it's got to be this one. Is it slope down 1, right 2? If I start here and I go down 1, right 2, am I in the line? No. It's got to be much flatter. So get rid of it. Same thing with C. This one has the y-intercept of negative 3 that we're looking for. And now is it slope, down 1, right 2, down 1, right 2? No, we're not on the line. Get rid of it. And then lastly, D. Here's the y-intercept, and then starting here, down 1, right 2, down 1, right 2. Okay, so far I would eliminate B and C, and I've got A and D, right, as two possible answers. Now we're looking at the second one, y equals negative 5x minus 7. Notice in A, again, I said this line right here has a positive slope. We don't know exactly what it is, but we know it's positive. And the point is, therefore, it cannot be negative 5. So we don't even have to count it out. We should be able to just look at this and know it's wrong because it doesn't have two lines with negative slopes. So therefore, D is the correct answer by process of elimination. Now, of course, you could spend time looking, okay, yes, the y-intercept of negative 7 matches, and if we count according to the slope, say we go up 5, left 1, or starting, wherever up here, go down 5, right 1, we would be on the line. The slope would match. But you don't need to spend the time doing that because we've eliminated the other 3 as wrong. Okay. Problem number 5. For this one, it is going to be a very simple problem because all you have to do is just technically divide by 6. And then you just get x plus 4 equals 6. And you can just leave the answer like that. Now, some people would instinctively distribute the 6 and get 6x plus 24 equals 36. And then go ahead and solve it. 6x equals 12. X equals 2. Now, just write that down here. Make sure we can see it. Okay, now the thing, if you do that, that's fine. It just takes a little more time, but it's really not, a significant amount of time. The thing you just have to remember is you're not solving for x, you're solving for x plus 4. So you have to remember to do 2 plus 4, and then that's equal to 6. All right, problem below that, problem number 6, we have a graph with a best fit line, and it's got, you know, various like actual point values on it. So it asks about when the skier's heart rate was 85 beats per minute. Um, so notice that the way this is set up, okay, we have 80, which is like right here, and we have 100, which is right here. So if you count it out, zoom in, I mean, you count it out, you have 1, 2, 3, 4 marks between them. So each tick mark on the x-axis is 5 beats per minute. So 85 is just going to be, you know, this line right here. And so this is the point that we're looking at. Okay? So it wants to know the difference between the actual oxygen uptake and predicted. So the actual is the actual point dot on the graph. So the actual value is just 1, because notice it's across from the, you know, horizontal mark of 1 here. So actual value is 1, and now I'm just going to delete some of these drawings. Okay, so now what's the predicted? Well, it's like if we would draw a line over here, it looks like it's halfway between 0 and 1, so maybe it's 0.5. So 1 minus 0.5, difference between actual and predicted, so therefore it's going to come out to be about 0.5. So the correct answer for this one is letter A. Again, all we're doing here is we're looking at the difference basically in the y values between a point on the graph and a point on the line. Moving on to the next page, we have something with probability and statistics. This problem number 7 here, you're given 2 data sets, and it wants to know about the mean of data set X versus data set Y. So for this one, first I will go through and just actually calculate them out, and then we'll just compare the numbers. So to get the data set, to get the mean, excuse me, of the data set, there's multiple ways you could do it. I mean, most common way is just going to be to add up all the numbers. So we have 5.5 plus 5.5 plus 5.6 plus 5.65 plus 5.66. All right, and then we just divide that by 5.582. So for the top one, the mean is 5.582. Then for the bottom one, here's the thing that can actually save you some time. Notice that this value matches this value, and this one matches this one, and this one matches and this. So basically, everything is the same except there's one extra value. And I'll talk about that more just after I finish here. So rather than retype all the numbers, I'm just going to copy them down, and then I'm going to add a 4 to it, hit enter, and now just divide by 6, because this one has 6 total numbers in it. 5.3183. Okay, 5.318. All right, so which mean is greater? Okay, obviously it's dataset X. So it looks like this one's going to be letter A. The mean of dataset X is greater than the mean of dataset Y. All right, now you can do this problem without actually doing these calculations based on what I just noticed, which is that dataset Y has every single value from dataset X, but it adds one more value, and specifically that value that it adds is much, much smaller or lower than all of the others. In other words, all the other values are like 5.5 to 5.66, which are pretty close together. But then when you add in a 4, that's going to bring the average down or decrease the average, because for dataset X, you know that the average is somewhere between all these numbers. You know, when you add them all up, you're going to get some value that's between 5.5 and 5.66. But if you add a 4 to it, that's going to pull the average down. So if you just looked at this problem and were able to figure out that the answer would have to be A based on that, I mean, that's fine. That's good. That means you have a good understanding of, you know, the mean or the average of a data set. But if you're not able to do that, just punch them into the calculator, work them out, and then compare them. All right, problems 8 and 9 both deal with this, you know, this function here. Basically, it's just a linear equation or a line. So for 8, all we're doing is just taking 10 and plugging that in for t. And that's it. And you can just do it on the graphing calculator. You know, it's just 0.025 times 10 plus 10.30. So we're just going to have 0.25 plus 10.30, and that should just come out to 10.55, but notice that just gets rounded up to 10.6. Because the problem says rounded to the nearest tenth of a micrometer. So correct answer is letter C, and that's it. You're just taking 10, plugging it in for T to this problem, working it out. No other work is needed. Now, in problem number 9, they're asking about the value of the 0.025 that's in front of the T, what it means. So this is the slope of this line, but really, slope is really the same as a rate of change. So essentially, the slope or the rate of change will tell you, in this specific example, how much the y is going to change for a 1 unit increase in the x. Or in this case, it's not a 1 unit increase in x, but it's a 1 unit increase in t. So if you look at the possible answer choices, it's going to be D, because 0.025 gives us the increase or the change in the y value, and here y is technically f of t, which is the length of this cell. So it's the increase in the predicted length of a yeast cell each minute. That's where the 1 unit thing comes in. So 1 minute after completing cell division. So D is the correct answer, and again, that's because the slope or the rate of change basically gives you the increase or decrease in the output variable, in the y variable, based on a 1 unit change in your x or your input variable. All right, problem number 10, you have another graph. You have a line here, and he wants to say, okay, so in this graph, it basically shows number of days down here, and then the amount of money he saved after, however many number of days. So it says, it's basically asking for which pair represents a possible amount of money that he has saved after X days. So if you look at all these points, there's only one of them that is either on the line or under the line. And that's going to be answer choice A, 18,50, which would be like right here. 1275 would be up here. Okay, that's not possible because it's above the line. 8100 is way up here. Not possible because it's above the line. And 4125 would be even higher, way up here. Not possible because it's above the line. So 1850 is the only point that is either on the line or below the line. Those are all the points that are acceptable for this situation. Because it says he plans to save up to $5 per day. So it's not necessarily equal to $5 per day. It could be less than that. But it can't be more than that is the point. All right, moving on now. Next page at the top, we've got problem number 11. Now this one on the QAS, there is a piece of information that is missing. So the correct answer to this, I'll just tell you, it's a letter B, okay, 0, 1. We know that line P here has a slope of -1 because it's down 1, right 1, or you could just pick 2 points on it and subtract them using the slope formula. Therefore, line Q, which is perpendicular to it, if you draw it, is going to have a slope which is the opposite reciprocal. So we take the -1, we put it on the bottom, we put it under 1, and we also take its opposite. So in the end, it just becomes +1 for line Q. This is P, this is Q. So line Q has a slope of +1, and the correct answer is 0, -1. So it looks like this. So if I had to guess, I would say that most likely the point that is missing right here that line Q passes through is 1, 1. But again, impossible to know that without actually seeing, the exact test in front of us. The reason I'm guessing 1, 1 is because it says also passes through, which implies that P passes through this missing point in addition to Q. And 1, 1 would make sense as, that's where they intersect. Okay, bottom of the page below that, we have problem number 12. Now, this is an exponential function. So the 10 that's in front here is just going to represent the initial amount of this radioactive isotope, or the starting amount. So the correct answer is going to be letter A. And just to briefly review exponential functions, this number out here, this is always, again, your initial or starting amount, whatever number that is. And then in here, in the parentheses, that's basically your exponential growth or decay rate. So if you look at this one, it's 1/2. So what that means is this is basically exponential decay, and essentially the amount is decreasing by half every time period. Okay, so it's like maybe it starts off at 10, then it will go to 5, then 2.5, then 1.25, and then so on, from there. And then over here, the T, that eventually ties into like how long the time period is for the item to either like grow or decay at whatever the rate is. So in other words, how long it takes for the item to decay by half, or to increase by whatever, 20%, 30%, whatever it is. All right, so now let's move back to the top of the page, problem number 13. So here we have a basic geometry problem with some lines, and 2 lines and a transversal, and they want to know which is sufficient to prove the lines are parallel. So the answer is going to be letter B, because W and Z are corresponding angles. And when you have 2 corresponding angles that are congruent, then the 2 lines that make them up are going to be parallel. The other 3 sets of angles are not any special type of angles formed by parallel lines. So W and Y are technically vertical angles, and they're always congruent regardless of whether you have 2 parallel lines or, like, say you just had this, 2 non-parallel lines. These are vertical angles, top and bottom. They're still congruent. What else? X and Y, these are just basically like consecutive angles or adjacent angles that are next to each other. Not necessarily nothing to do with the lines being parallel, because they're not formed by line M. They're only formed by L and K. And then X and Z are not any special type, because one's up here and one's down here. So they don't have any type of special relationship. So it's just W and Z, the corresponding angles. 14, we have another data set problem where just make sure we can see the whole problem here, and then we'll bring the calculator back, where we basically have 2 dot plots, and it wants to ask about the difference between the mean and median. So first, if you are unable to look at these and just like figure out the difference between the mean and median just by looking at them, that's totally fine. Go to the graphing calculator and plug in the values on the calculator, and then just compare them. So let's start off with the mean. So for data set X, we have, let's see, 20, 21, 22, 23. Put them in reverse order, but it doesn't matter. Plus 25, plus 25. And then we have 26, 27, 2 28s. Okay, divide that by 6. 25.16. So whatever, we'll just jot that down here, 25.16, and that's the mean. And for the second one, it looks like we've got a 21, a 24, 2 25s, and then a 28 and a 29. Now notice, technically the sum of all the values in y does not equal the sum of all the values in x. Like the first one was 151, this one's 152. Therefore, I know that the mean is not the same for each of them. So I technically don't need to continue with the calculation, but if you didn't recognize that, that's fine. We can just now go ahead and divide it by 6, and you'll see that the numbers are different. It's 25.3. Okay, so the means are not the same, so therefore we can get rid of anything that has 1 in it, so we can get rid of that. So now it's either the medians are the same or nothing's the same. Okay, so the median, this one is relatively easy just to look at because the median is just going to be the middle point in a data set, when you have everything from ascending order, smallest to largest. But since there are an even number of values here, since there are 6 values, technically it's going to be um, the average of the 2 middle values. So what I mean by that is start with the top one here, start on the left, start on the right, cross out a value, cross out a corresponding value. Okay, and then you're either left with 1 or 2 values in the middle. Here I'm left with 2 values, but since they're the same, we just take the average of them, which is just the same number. In other words, it's the average of 25 and 25, which is just 25. So the median will just be 25, and the same thing happens for y. Cross out 1 on one end, 1 on the other end, keep going. You're left with these two. Average of 25 and 25 is still 25, so therefore the median for y is 25. So what is the same? Well, the median. So correct answer is just going to be letter B. All right, moving to the top of the next page. Here we have this problem here that deals with world population. And basically what's going on is, okay, the population of this Persian Empire was whatever, 4.4 million. However, it was 44% of the total world population. So what is the total world population? Two different ways you could set this up to solve it. I'll show both ways. I mean, they're really not that much different than each other. So one way is just translate it straight as it's written. 49.4, and I'm just going to keep it, I'm going to ignore the million for right now and just put that in my answer at the end. Okay, now was is really the same. It's the same as is. Is as an equal sign, but was just indicates past tense. So we can just pretend this is and make it an equal sign. 44%, which as a decimal, I'm going to turn into 0.44, of multiplication, world population, that's our unknown, that's our x. Okay, and now you could just divide both sides by 0.44. And then if you do this on the calculator, you should just get as an answer 112.27. And of course it's million. And that's just going to round to 112.3. Correct answer is going to be letter D. Now, if you're not good at translating a set of equation that way, here's an alternate way you could just do it with proportions. Okay, you could say, okay, the Persian Empire, 49.4 million. Total world population, X, unknown. So on my proportion, I have Persian Empire's values on top, world values on bottom. Then on the right side, I put the percentage. Persian Empire, 44%. World population, the whole thing, well, that's 100%. And now you just cross multiply, and you get 44x equals 4940, and then you just divide by 44. And it's really the same equation that you're solving. It's really the same calculations, and you get the same answer. 112.27 million, approximately 112.3 million. Okay, below that we have problem number 16. Here we have another kind of best fit line, like with a bunch of points also drawn on the graph. And so in this one, it's asking for the best interpretation of the y-coordinate of the y-intercept. So the y-intercept is going to be right up here. So notice the value is 6 for the y-coordinate value. And notice that the corresponding x value, for this is 0. So in other words, the y-intercept is at the point 0, 6. So now if you go through these answers, you can eliminate a bunch of these just right away. So for the value of x equals 6, no, the x value is 0. It's not 6. For a y-intercept, x is always equal to 0. Okay, for the y value 0, no, it doesn't go through the origin. That's wrong. For the value of x equals 0, yes, good. Line of best fit predicts a y value of 6. Okay, this appears to be correct. Answer choice C. And then for D, for a y value of 3, no, not correct. We know the y value is 6, and that's it. So you can just eliminate, the 3 wrong ones quite easily, just once you've identified where the y-intercept point is. Okay, back at the top of the page, problem number 17. This one, there are two ways you could do this. So the first way is to actually do it out with the formula. So it wants to know the coordinates of where it crosses the x-axis. So think about this. Here we have a graph of a line, okay? The point where it crosses the x-axis is the same as the x-intercept. And the x-intercept, right here, will always have a y value of 0. Notice that all the answer choices have a y value of 0. So we just take this equation, we just plug in 0 for y, and then we just solve for x. So 0 times 3 is just 0. So 4x equals q. So x is just going to equal whatever q divided by 4 is. So therefore, the correct answer to this problem should be letter B, q over 4 divided by 0. Now, let's say the q, whatever is confusing you, you're having difficulty with it, that's totally fine. You could instead use the approach of picking numbers. And let's give q a value. So let's let q equal to, I want to make it something that easily divides by 4, so whatever, I'll just pick 12. Okay, so now let's say I let q equal 12. Just get rid of all this work here temporarily. And so I've got 4x plus 3 times, we still plug in 0 for y, equals 12. This is my hypothetical line. So 4x equals 12. Now I get x equals 3. Okay, what you have to do now is we go to the answer choices and we put 12 in for q and we see which of those expressions equals 3. So in A, we have 12 divided by 3. That's 4. That's wrong. That's not 3. B, we have 12 divided by 4. That's 3. That's going to be the correct answer. C, we have 3 divided by 12. That's 1 over 4. Wrong. And D, we have 4 divided by Q. 4 divided by 12, 1/3. Wrong. So that's just an alternate way to do it if the Q is confusing you or giving you trouble. All right. Below that, problem number 18. Okay, in this one, it's a little confusing, and I'll show why in a second. So you have this jet, it's starting at 10,000 feet, and it climbs to 30,000 feet. And it's a constant rate, which means it's a linear function. They want to know what was its altitude in feet 14 minutes after the climb began. So basically all we do is we find the slope, or the rate of change, which is, 30,000 minus 10,000, over essentially 20 minus 0, because it's 20 minutes is the time period. So if you do that, you get, well, it changed 20,000 feet in altitude over a period of 20 minutes. That means basically its rate of change was 1,000 feet per minute. So 14 minutes times 1,000 feet per minute, just write it down here, means that it's going to increase. So again, it's 1,000 feet per minute, again, and it's a time period of 14 minutes. So that means that the net change in altitude is going to be 14,000 feet. However, be careful, that is not the answer, because it started at 10,000 feet. So you have to remember to take the 10,000 feet and add that to the 14,000 that it climbed. So in other words, its total altitude after the 14 minutes is going to be 24,000 feet. Correct answer here is going to be letter C. A lot of people will pick A because they will forget to add the 10,000 feet to the 14,000 value that you calculate. All right, next page, number 19 at the top. All we have to do for this problem is take the left side and multiply it out and then match up the coefficients of the corresponding terms. So first thing I'm going to do is take the x plus 2, which is squared, and FOIL that out. So if you write that out twice, x plus 2 times x plus 2, and then do FOIL, you're going to get x squared, and I'm just going to skip one of the steps, plus 4x plus 4. It's technically x squared plus 2x plus 2x plus 4, but I just combined it into just plus 4x in the middle. Okay, then all those terms are just multiplied by the x in front, so if you distribute that, you get x cubed plus 4x squared plus 4x. And now we just match, I'm just going to write it directly underneath it, x squared, x cubed, excuse me, plus bx squared plus cx. So now you can easily see b has to equal positive 4, c has to equal positive 4. Therefore, what's the value of b plus c? Well, it's just 4 plus 4, and it's going to equal 8. And that's it. You're just doing some multiplication. Continuing now with problem number 20. So this problem basically has a rational function that you're given, and it wants to know which of the following could be the graph of this rational function, which has a variable. Basically, it's a constant k, but the point is we don't know its exact value. So first I'll show you, I guess I would say the traditional way to figure out which graph is correct, and then I'll show you how you could just easily use the graphing calculator to figure it out. So first, if you notice that you set the denominator equal to 0 and solve that, you will get x equals negative 1. That means there is a vertical asymptote at x equals negative 1. So when you go through the answer choices, a vertical asymptote is, basically a dashed line that separates, in this instance, the two parts of the graph, where one side goes to infinity, the other side goes to negative infinity. So notice that only occurs in graphs A and C. In B, the asymptote is to the right of the y-axis. It looks like maybe it's at positive 1, so that's wrong. And in D, it's to the right of the y-axis. It looks like maybe it is at positive 1, so that's wrong as well. So we're down to A and C. Then next, what I would notice is, and I'm going to just rewrite the problem by switching the terms, the horizontal asymptote of this function will be equal to its leading coefficients from both the numerator and the denominator, because the degree of the top, which is 1, x to the first, is the same as the degree of the polynomial on the bottom, which is also x to the first. So they have the same degree. Therefore, the horizontal asymptote, if it exists, which it does, will be equal to the leading coefficients of these two terms. So in other words, it's going to be y equals negative 1 from the top, the number in front of the x, or the, in front of the x term, over positive 1, the number in front of the x term on the bottom, or y equals negative 1 will be the horizontal asymptote we would expect to see here. So in A, this looks like it is possible because y equals negative 1 would be below the x-axis. However, in C, the horizontal asymptote, just kind of like dividing the graph into two parts, from a vertical perspective, is above the x-axis. So this one will be wrong. So by process of elimination, the answer is going to be letter A. Now, here's how you could use the graphing calculator to solve this problem in possibly a quicker, easier manner. Just go to the y equals screen, and now what I'm going to do is I'm just going to graph an example function where I'm just going to plug in a value for k. So on the top, let's make it, whatever, positive 2. So I've got 2 minus x, and then on the bottom, 1 plus x. So now I'll go ahead, just graph that out. And now it's not going to look, identical to the answer choices here, but there's one that it will look much closer to than all the others. And so now if you look at them, again, look at the, the graph here, we can see that For the right side, it goes below the x-axis as it moves all the way to the right, and it goes just to the left of the y-axis as it goes to infinity. So again, this part in B doesn't match. It's both above the x-axis and it's to the right of the y-axis. In C, it's going the wrong direction. D, it's just going the wrong direction. So we could eliminate those three right away and then notice, yeah, it looks pretty similar to A. So that's an alternate method you could use to get this problem if you have a graphing calculator, which I always recommend for the SAT. Now, continuing back at the top of the page again, problem number 21. So here you're just given information about a circle. You are told its center and you are told its radius. So hopefully you know standard form equation for a circle, x minus h squared plus y minus k squared equals r squared. The radius is 2, so therefore here we're going to plug in 2 for r and square that, so it's going to be equal to 4. Therefore, A is gone, C is gone. Now, we have to plug in H and K, and H and K are just each going to be positive 1. So this H is going to be replaced with a 1, and this K is going to be replaced with a 1. So we get the final answer for the standard form equation of the circle. Letter D, x minus 1 quantity squared plus y minus 1 quantity squared equals 4. And that's it. Nothing else to do. Just you need to memorize the standard form equation of a circle. Below that, problem number 22, we have a right triangle. And there are technically two different ways you could do this one. So the first way is to know the 30, 60, 90 special right triangle rules, because that is the triangle we have here. We could fill in this 60. And so notice that 5, which is across from the 30, which is the short leg, and AC is the hypotenuse up here. So hopefully you know the rule, which says that the short leg to the hypotenuse is basically a scale factor of 2. So we just multiply by 2. 5 times 2 is going to equal 10. Correct answer is going to be letter B. However, here's an alternate way you could do that if you forgot the 30, 60, 90 right triangle rules or formulas. If you know basic trig, then you could just say, all right, sine of 30 equals opposite, which will be 5, or side BC, over hypotenuse, which will be AC, what we're trying to find. And then we could cross multiply this, and then just divide by sine 30, which technically it turns out to be equal to 1/2. And so AC is technically equal to 5 over, this is just 0.5 or 1/2, and if you do that, you're just going to get 10. So that's an alternate way that you could find the answer to this problem if you did not remember the 30, 60, 90 special right triangle rules. Continuing now at the top of the next page. Here we have a fairly difficult problem, but I'm going to show you multiple ways that you could solve it. So the first way is kind of the theoretical or reasoning way. So I'll just explain that quickly. But if you don't understand that or don't follow that explanation, that's totally fine. Pay attention to the other methods. So what's happening here is you have some point on the function. Then you have another point, and what you've done is you've moved 1 unit to the right for the x-coordinate value. That's what the a plus 1 means. So it's like I'm at, whatever, 4 comma something, and then my next point would be like 5 comma whatever. And the point is that when you do that, the y value, the y coordinate, which originally is b, will end up being multiplied by 1/3, i.e. divided by 3. So in this example up here, my 6 would end up being multiplied by 1/3, and that would then turn into 2. So that only ends up happening for one of these functions here. The function that it's going to end up happening for is letter B. And the reason that happens is because notice that one has a 1/3 raised to the x power here. So for every increase in the value of x, say by 1, you're going to multiply by another 1/3. So that's what makes B the correct answer. Okay, again, that's the theoretical like explanation behind it, but here are two other ways you could solve that if you didn't know that or didn't understand that. So, first method, picking numbers. I'm going to start with a equal to 0, and then what I'm going to do is I'm going to go down through each of these and I'm going to find out what the corresponding y value is. So in other words, my x coordinate is 0 for each of these, and then my y values are going to be, for the first one, notice all of these are raised to the 0 power, which is just 1. So really, my y values are just going to be the numbers in front, because it's going to be like 1/3 times 1, 12 times 1, 12 times 1, 1/3 times 1. Okay, now I add 1 to my a value, so now my new a is equal to 1. Okay, so I'll fill that in for all the x coordinate values. And now if my for my b value, or excuse me, for my y coordinate, I'm taking 1/3 of b. B was the original y coordinate values that I calculated from the function. So I take 1/3 and I multiply it by 1/3 and I get 1/9. Then I take 12 and I multiply it by 1/3 and I get 4. Then I take 12 and I multiply it by 1/3 and I get 4. And then I take 1/3 and I multiply it by 1/3 and I also get 1/9 again. So again, what I've done so far is I picked a value for a as a starting x-coordinate. I plugged that in to each of the functions and I found what b had to be based on that a value. Then I found my second point by adding 1 to a, so 0 plus 1 is 1. Then to find the new b value, I didn't plug that into the function. What I did is I multiplied the original b value times 1/3. So now what you have to do is, technically now I'm going to take the a value of 1 and I'm going to plug that into the functions and I'm going to see which of them gives the same output as my new y coordinate values, over here for my second point. So this you could also do on the calculator, but I'm just going to do it by hand because it's really not going to be that difficult. So like for a, it's going to be 1/3 times 1/12 to the first power, which is 1/36, 1 over 36. For b, it's going to be 1/3 to the first, which is 1/3. 12 times 1/3 is 4. For c, it's going to be 3 to the first, which is 3 times 12, that's 36. And then for d, it's going to be 1/3 times 12 to the first, which is just 12. That times the 1/3 is 4. So now, which of these values match, the values I have up here in my second column? So 1/36, 1/9 doesn't match, wrong. 4, 4 matches, keep it. 36, 4 doesn't match, wrong. 1/3, 4 down here and 1/9 up here don't match, wrong. So therefore, that's further proof that the correct answer is B. This was using the strategy of picking numbers, and that's an alternate way you can get it. Now, just real quick, here's a third way you could get it. I'm not going to go through and do this for all 4 answer choices, but I'll just show you an alternate way you could have done it is you go on the graphing calculator, you graph out the answer choices, and then you go to the table of values. So I have 1/3 here to the x power. So I'm just going to graph answer choice B. This just showed that one is correct. All right, so now I go to the table of values. And now what you're looking at is when I increase the x by 1 unit, is my y value being multiplied by 1/3, i.e. being divided by 3? And you can see starting here at -1, the answer is yes. Notice how the y value goes from 36 divided by 3 is 12. 12 divided by 3 is 4. 4 divided by 3 is 4/3, or 1.3 repeating, and so on. So that's my confirmation right there, just from these couple of points, that B is the correct answer. And again, technically, if you're going to use this method, you would have to graph the first one and check the table and then do the second one. And then you could probably stop there because that one is correct. But you could technically do all 4 of them as well. All right, so now continuing with problem number 24 at the bottom of the page. So in this one, we're told that basically 90% of this volume of this iceberg is below the surface. That means 10% is above. So, just to give like whatever a quick picture, maybe it's something like this. 90% down here below, 10 whatever, 10% above. Okay. And A is the volume of the iceberg that is above, and V represents the total volume. Okay, so just this part on top here is A, V is the total volume, and then we want to basically relate V to A. So here's the thing. Just A, notice in my picture I've drawn, okay, A is 10% of the overall total. So the correct answer to this one is going to be letter C, because that basically just describes exactly what I said. A, which is the volume above the surface, is equal to 10% or 0.1 times V, the overall volume. However, that's the theoretical explanation. If you didn't understand that or didn't follow that, here's an easy way to do it. Just use picking numbers, okay? Say that the overall volume is 100. Then 90% of that is below the surface. Excuse me. So that would be like 90 whatever units, cubic whatevers. And then the remaining 10%, 10 things would be up here. So now V is 100 and A equals 10 in this scenario. So plug all those in and see which equation makes sense. So for A, you have, all of them are going to be 10 equals. So for A, you have 10 equals 10 times 100. Okay, obviously wrong. B, you have 10 equals 0.9 times 10. So 10 equals 90, obviously wrong. C, you have 10 equals 0.1 times, excuse me, it should be times 100, not times 10, that I'm plugging in for V. So 10 equals 10, that one works. And then in the last one, it would just be the 0.1 times 100, which is 10, and then plus 0.9 or 10.9. Okay, that's obviously wrong. So that's an alternate way you could do this by picking values. Pick a value for V, then based on what they tell us, calculate what A has to be, and then plug A and V into the 4 answer choices and see which one is true, which one makes sense. All right, the next problem at the top, problem number 25. This is again another problem, actually 3 in a row, that you can use picking numbers on. So first I'll show the theoretical way, but then after that I'll show how you could use picking numbers to figure it out. So basically, if you match everything up, it tells you the ratio of money in 8 states to the ratio of money in Florida was 11 to 8. So I'm going to just make a fraction here with 11 over 8. And on the bottom is Florida, and on the top are the 8 states. Okay? And then, excuse me, in the 8 states, they collected X total dollars. And then they want to know what the value of the dollars collected in Florida is. So whatever, I'll use a different letter. I'll use Y just to represent that. And so as long as you match everything up and put the 8 states, say, both on top, and you put both Florida values on the bottom, then we can just basically cross-multiply this and rearrange it to solve for the Y, the total amount of money collected in Florida. So 11Y equals 8X. Divide by 11. Y equals 8X over 11. So the correct answer for this one is going to be letter A. Now, let's show you how you could use picking numbers again to solve this. So let me just clear out some of this work here. All right, so let's say the ratio of the money collected in all 8 states of Florida is 11 to 8, right? if a total of X dollars was collected in all 8 states. So now instead of X, I'm going to plug in a number for that. So I'm going to use 22. The reason I'm going to do that is because 22 is just a nice multiple of 11. So notice that, I multiply it by 2, I go from 11 to 22. So that means if $22 was collected in all 8 states, then in Florida they collected $16. Again, got to be the same scale factor. So now what I can do is I can take these 4 expressions. I'm going to plug in 22 for x, and only one of them is going to equal 16, okay? Because that's technically what we're solving for. So right away, notice C and D are out. So it's down to A and B. So it's either 8 times 22 divided by 11, or it's 11 times 22 divided by 8. And I'll just tell you, it is the first one that's going to be correct. The first one is equal to 16. The second one is equal to 30.25, which is wrong. So therefore, correct answer again is going to be letter A, and that's using the strategy of picking numbers to solve it. Moving on, here we have 2 different data sets of numbers, problem number 26. And it's asking us about differences between the mean and the standard deviation of both. So the mean for each of these is going to be 5. And the reason you can get that just by looking at them is because notice the most frequent value is directly in the middle, 5 for each. Excuse me. And then on either side of it, the distribution is uniform. In other words, like if you go down 1 from 5, you're at 4, and there's 3 values. And you go up 1 from 5 to 6, and there's 3 values. So that's how I can tell that the mean will be equal to exactly 5 in both the one on the left and the one on the right, because they're uniformly distributed. However, if you weren't sure of that, you could technically go to the calculator and you could plug in, and you're just going to multiply like the frequency of each times the value. So 3 times 4 plus 6 times 5 plus 3 times 6, and then add all those up and divide by the total number of values. I guess it would be 3 plus 6 is 9 plus 3 would be divided by 12 in this first example. Oh, and it tells us right here it's 12 numbers. And then you could get the mean, and you could compare in that way. But the point is you don't need to do that. So the means are going to be the same. Therefore, we can automatically cross out C and D because those have one data set with a greater mean than the other. So now the question is, what about standard deviation? So standard deviation is the basically how spread out the values are relative to the mean. Are they very closely bunched, or are they spread out much further apart? Closely bunched means a low standard deviation. Spread out further apart means a high standard deviation. So hopefully you recognize it's going to be higher in B because here you have values that are 2 units away from the mean at 3 and 7, whereas in the first one you don't. You only have 1 unit above and below. So dataset B has a higher or greater standard deviation, therefore correct answer is going to be letter B. Next to that, problem number 27. Here you're given a quadratic, you're given a bunch of points, a scatter plot essentially, and you're asked for the appropriate, which of these is most appropriate quadratic model. So there are many ways that you could do this. What I would recommend, I think what the easiest way is, I would take a point on the graph right here, because if you take this thing here and you kind of draw kind of like a best fit curve, you can see that like most of the points are pretty close to it. I would take this value where x is 7 and y is like 11 and a half. We're going to plug in 7 for x, and we're going to see which of these gives us a value closest to 11 and a half. So just to save time, we will go to the calculator. So 4 times 7 squared. So wrong exponent button. Okay, delete that. There we go. 196, okay? Not 11.5, not anywhere close to it. It's gone. So next answer, now I'll just change the number in front. Nothing. That's the only thing that's changing, are the coefficient values, or the a value. Okay, 98, clearly wrong. Next, again, we'll copy it down. It's 1/2, so I could just type in 0.5, but just to show you that we can put in 1/2 as a fraction. Okay. 24.5, it's wrong. So at this point, it pretty much has to be D, but we'll check it just to confirm. Okay, 12.25. That's close to 11.5. It's not identical, it's not exact, but it's the one that's closest and in the ballpark. So therefore, correct answer is going to be D. Also, a second alternate way you could do this is you could have graphed these out and then just gone to the table of values and like looked, for some of these points and seen which ones matched as well. But I think it's quicker just to like plug in an x value and just evaluate it rather than having to graph, all 4 of them out. Okay, moving on to the next page. At the top, we have problem number 28. So here we have more quadratic functions, and it wants to know about which one has a maximum value of m, where m is a positive constant. So here's the thing. When we talk about a maximum value of a quadratic, what we're technically talking about is the y-coordinate of the vertex. So first of all, for these functions to have a maximum, they will have to open down. Okay? So m is positive, but the function's opening down, which means a has to be negative, or a has to be less than 0. So therefore, this one is out. The other 3 can all remain for now. And like I said, the maximum value of a quadratic is technically equal to the y-coordinate of its vertex. Or basically, like if you think of h comma k, it's really the k value. So essentially what we're saying is, if you think about vertex form, which I've written out here, like this right here is your maximum value. Okay? This k added at the end. So the correct answer for this one is going to be letter C. And the reason is because it's the one that has a number added at the end here on its own, which matches the vertex form. Okay, now if you didn't understand that, if you didn't follow it, that's fine. There are alternate ways to solve this. So let's just say that I would let m equal 2. Okay? Alternate ways to solve this are to go to the graphing calculator and now plot some of these graphs out. So, for example, the first one's going to be plugging in now m for 2. I'm plugging in 2. It's 2x squared. Okay, does this have a maximum value? No, it doesn't, so get rid of it. Now, let's go to answer choice B, and I'm going to do negative 2x squared. So again, this is another problem where you could do picking numbers, but it's best to also use the calculator in conjunction with it. Okay, so now we do have something that has a max value, but is the maximum value at 2? Well, you can probably tell by looking at it that the answer is no, but you can technically confirm it by going to calculate maximum. Now for my left bound, I'll move to the left of the high point. For my right bound, I'll move to the right. And now for my guess, I'll go in the middle. Okay, and hit enter. And the maximum, it's technically going to be, it's supposed to be 0, 0. I mean, it comes off with these ridiculously small numbers because of, whatever, rounding and stuff. But it's basically 0, 0. But the point is, the y value itself is not 2. That's what we're looking for. And then if you go to C and you graph that one out, And I'll just show you that real quick. Won't bother doing D since that one's wrong. And you could go through the same steps to find the maximum value of the function. Okay, it looks like it's happening right there where it was on 0, 2 already. Okay, left bound, scroll to the right, right bound, back to a guess, enter. Okay, right there, maximum value occurs at y equals 2. So that's just confirmation that this is correct because we said m was 2. Again, alternate way you could solve this problem using picking numbers along with your calculator. All right, now below that we have problem number 29. This one again is another problem where picking numbers can be very helpful to solve this. So a quantity is decreased by 45% of its value. The result of that is x, which gives the value of the original in terms of x. So, okay, I'm going to start with 100. It's decreased by 45%, i.e. we subtract 45% of the original number. That just becomes 45. So our resulting value is now 55, and that is equal to x. So I plug in 55 for x into all these possibilities. One of them will give me the original quantity, which is 100. The other three will not. So if you can't just look at it and figure it out, we'll just do it on the graphing calculator or any calculator real quick here. Answer choice A, is it 100? No. Answer choice B, is that one 100? It is, so this one's going to be correct. I mean, I'll just tell you C and D are going to be wrong because they're each going to be less than 100. But the correct answer for this one is letter B. Again, easiest way to do this one is to just use picking numbers. Now, at the top of the page for problem number 30, this is just basically a unit conversion problem. And it's actually not that difficult because they give you here, the conversion between miles and yards. So the area of this forest is 3 square miles. Okay, so we got 3 square miles, but they want to know it in square yards. So all we have to do is basically multiply by the conversion factor, 1 mile, 1760 yards, just twice. Or you could also think of it as just taking the conversion factor and squaring it. So this one is just 3 times 1760 times 1760, and that's it. And it comes out to the 9,292,800 square yards. And correct answer is letter D. No more work is needed. Move on to the next problem. All right. Starting now with problem number 31, the first of the grid-in fill-in questions. So the ratio of students to teachers is 18 to 1. So, okay, 18 to 1. And again, that's students to teachers. The school has 105 teachers. How many students does it have? So notice I put this in the wrong spot. The 105 needs to match up with teachers on the bottom, and X, number of students, would go on top. And now we just cross multiply, and we should get X equals 18 times 105, and that's just going to be 1890. So the answer you would fill in, or you would grid in 1890, 1890, and that's it. No other work needed for the problem. Now, top of the next page, problem number 32. For this equation, it says that if the equation has no solution, what does the value of b have to be? Well, basically an equation has no solution, or linear equation, when you have the same exact x terms on either side, but the y terms, or the number terms, excuse me, are different. So this value right here has to be 2. Because then you would have 2x plus 7 equals 2x plus 5, And if you subtract 2x on both sides, what happens is you get 7 equals 5. That is a false statement. That is not true. There is no value of x that you can plug in that makes this true. So therefore, the value of b has to equal 2, and you just grid in 2, nothing else. Below that, problem number 33, it's a probability question. So if you select a number at random from 1000 to 1999, what's the probability that the number is greater than 1499? So first of all, there are a total of 1000 numbers that we can choose from. So the denominator of our probability is going to be 1000. It's already given. But for the numerator, basically I would think about it this way. So what's the probability it's greater than 1499? So that means basically 1500 to 1999. So 1500 and then 1501 to 1599. Okay? Those in total represent 100 values. Okay, you've got 1 to 99, and then you've got the double zero, or the 0 as well. So there's 100 values in like the 1500s, in the 1600s, in the 1700s, in the 1800s, and in the 1900s. Therefore, there are 500 possible numbers you could pick, which would have a value greater than 1499. So this one's just 500 over 1,000, or just 5 over 10, or really it's 1/2. You could grid it in as 1 divided by 2, or you could grid it in as just 0.5. Either would be considered acceptable for that problem. For problem 34, there are multiple ways you could solve this. Now, I think the way they want you to solve this is they want you to notice that if you take the first equation and you subtract from it the second equation, you get 3x minus 2x is 1x, 4y minus 2y is positive 2y, and 35 minus 15 is 20. Okay, and therefore the answer turns out to be 20. However, maybe you didn't recognize that or see that you're supposed to do that. If you didn't, that's fine. Then what I would do for a second or alternate method is I would solve this system of equations. I would get my x and y values, and then I would just do x plus 2y. Now, I'm not going to bother solving it by hand because we have the graphing calculator. So I'm going to use, since these lines are both in standard form, I'm going to use matrix properties. So first thing I need to do is enter in a 2 by 2 matrix. And I'm going to put in the numbers of 3 and 4 and 2 and 2. Okay, then I need to raise that to the negative first power. Don't worry about why, that's how we do it. Okay, then I need a matrix with 2 rows but only 1 column to put the 2 numbers in. And now I'm going to plug in the 35 and the 15. Alright, now I have my answer. My x is negative 5, my y is 12.5. So now for x plus 2y, I'm just going to do negative 5 plus 2 times 12.5. 20. So correct answer, and again, that took me maybe a minute, 90 seconds at most, to solve it out and then just calculate it all on the graphing calculator. Okay, back to the top of the page. Problem number 35. Excuse me. So this one, it is much, much quicker if you remember the basic formula that the sum of the solutions to a quadratic equation is equal to negative b over a. Again, that comes from the whole ax squared plus bx plus c equals 0. So in this problem, b is equal to negative 3. A is equal to positive 2. So the opposite, or negative b over a, is equal to the following. The two negatives cancel out, so we get 3 halves. You could also grid this in as 1.5 if you wanted to. So either 3 halves or 1.5. Now, if you don't remember that, unfortunately this one doesn't factor. So you could go through the, process of like using quadratic formula or using um, completing the square. If you do that, I'll just tell you the answer should turn out to be basically, let's see here, 3 plus or minus root 47I all over 4. Okay, those are the two solutions. So now what happens if you go to add them, like basically it's like 3 plus root 47I over 4 and 3 minus root 47I over 4. The two I parts cancel out, and so you just end up with like 3/4 plus 3/4. That turns into 6 over 4, and 6 over 4 just reduces to 3 halves. So you can get the same answer, but it is so much longer and it is a lot more work than just memorizing the formula that the sum of the solutions to any quadratic equation is negative b over a. Also, just so you know, the product of the solutions will also be equal to c over a. Just something else to be aware of. Okay, now in 36, they're testing the same, kind of concept, except here you have to do more work first before you can actually solve the problem. So what you have to do is you have to FOIL out the right side and get all the terms equal to 0. So if we go ahead and do that, and now I'm going to move over the x and the 2, and we'll get 0 equals x squared minus, whoops, I should actually combine the like terms first. So let us make this minus 3x. Okay. 0 equals x squared, and now it's going to be minus 4x, and then minus 12. So now you could also, again, use the shortcut formula, negative b over a, which is just going to be the opposite of negative 4 over 1, and that will equal positive 4. Or this one's easy to solve by factoring. It's going to be x minus 6 times x plus 2. So your two solutions are positive 6 and negative 2, and if you add those together, you get 4 as well. So what you would grid in here is just the number 4. All right, the last two questions deal with this table on the left side. So in problem number 37, the number of registered women voters, was P% of the total population. What's the value of P? So this one is actually not difficult. All we're doing is taking the number of registered women voters, which the total down here is 81. Now it's million, but we can just keep it as 81 because the other number's in millions too. And it's what percent of the total? Well, the total is 122 million, or we'll just keep it 122. So you just divide this out. Now, this comes out to like 0.66393. So notice that this is the decimal. You convert this to a percentage by multiplying it by 100, and we get 66.393%. But the question says, what is the value of p to the nearest whole number? So now you have to round it, and you should only basically give 66 as your answer. It's 66%, but you, of course, don't give the percentage. You can't grid that in. So you would just grid in 66, and that's it. Nothing else to do on that problem. Now, for the very last problem, problem number 38. If you select a woman at random, 45 to 64 years old. Okay, so we're looking in here. What's the probability of selecting a registered woman voter rounded to the nearest 100th? So we're only choosing from the population of 45 to 64. So that means our total outcomes or total choices are the 42 million women in that age group. And the favorable ones are the registered women voters, of which there are 30 million. So this one's just 30 over 42. If you divide that out, it comes out to 0.71428. They want it rounded to the nearest hundredth. So you have to round this. Basically, you have to round the 1, and the 1 is going to stay a 1 because the 4 to the right of it. So the final answer you have to put for this one is 0.71. You cannot like fill up the answer thing. You cannot put 3 decimal places or anything. It's just 0.71, and that's it. So thank you for watching the solutions to this October 2021 QAS, this specifically the calculator section here. If you like this video, if you interested in my other videos, make sure to click the thumbs up on it, subscribe to my channel, and sign up for notifications as well. That way you'll find out whenever I have another new math-related video posted. But otherwise, if you have any questions or comments, leave them on the video below, and I will answer them.